So here's your first video from Chapter 5. We're going to talk about 7 laws of exponents. We'll cover an 8th in a later video. Today I'm going to move through these pretty quickly so that you can get to practicing to see how well you remember these from your Algebra 2 and Algebra 1 classes. So here's our first law of exponents here. The key is the b's. The b's need to be the same. You need to have the same base in order to perform basically all of these laws. Since your b's are the same, what this is telling you is if you're multiplying the bases, so b to the x times b to the y, you can add the exponents. We get b to the x plus y. So if we take a look here, x cubed times x to the negative second, we can add the 3 and the negative 2, which gives us x to the 1, which we know we can just write it as x. A little more complicated here, there are 2 different bases we're dealing with. We have x to the 5th and x cubed, and then y to the 4th and y to the negative second. We can only combine like bases, so this is going to be x to the 5 plus 3, and then y to the 4 plus negative 2. So our final answer here will be x to the 8th and y squared. For rule number 2, it's pretty similar to number 1, except we're dividing bases. Again, your bases have to be the same. They both need to be b's. As in the last slide, multiplication and addition went together. Here, when you're dividing the bases, b to the x divided by b to the y, division is going to be paired up with subtraction. So your answer here would be b to the x minus y. So if we slide this out of our way, we have a little more room. Down here, we're going to have x cubed divided by x to the negative 6, so we can subtract negative 6. You know that's going to end up as x to the 9th if we make this a plus positive. So that gives you that first one. Again, like our second example from slide number 1, we can only combine the x's and the y's since they have the same base. So this becomes x to the 3 minus 5 and y to the negative 2 minus 1. So this is x to the negative second times y to the negative third. Now, by the time we get to the end of this video, you will not be able to leave your answer like that. We haven't talked about this rule. We'll talk about negative exponents. But as far as this goes, what you need to know is that when you're dividing bases, you subtract the exponents. This third rule is sometimes called power of a power because you're taking b to the x power and then raising that to the y power. When that happens, and usually you'll see that's denoted by parentheses, you multiply the x times the y. So again, rule number 1, when we had b to the x times b to the y, we were adding. Now it's b to the x to the y, or again, the power of the power, we're going to multiply. So down here we have a couple quick, easy examples. X squared to the 4th, we can multiply the 2 and the 4. We end up with x to the 8th. Here on the right side, we're going to end up with z to the negative 14th. Again, we'll talk about negative exponents later, but for right now, that's as far as we can go. Negative exponents can be a little bit tricky. So rule number 4 tells us that b to the negative x is the same thing as 1 over b to the x. So if we use that rule, think about this first example, w to the negative third. If I take w to the negative third, based on our rule, that's telling me that that's 1 over w to the third. If we look at this second example, 1 over w to the negative second, if I start that up here, well, w to the negative second I know is 1 over w to the second, so this is going to be 1 over w to the second. If we think about dividing fractions, we know that we can keep change flip this. So we're going to have 1 times w squared over 1, which just gives us w squared. One way I like to look about this, which may work for you, it may not, if you have something like w to the negative 4th over w to the negative 5th, what this really looks like is 1 over w to the 4th over 1 over w to the 5th. So all I'm doing there is rewriting those using this rule up here. This is our rule number 4. If I keep change flip this, we get 1 over w to the 4th times w to the 5th over 1, which is w to the 5th over w to the 4th. So what you can see is from our original problem to our final answer, basically we switch the 4 and the 5 and drop the negative. So I like to think of it as an upstairs downstairs kind of thing. If you have w to the negative 4th upstairs, that can go downstairs and become positive. Similarly, the w to the negative fifth, which is downstairs, can become w to the fifth upstairs. That's how I like to look at it with some complex problems. We can talk about this more in class if you need clarification or want to learn more about this, but I think that might help you moving forward. This, I think, is by far the easiest. Number 5 says b to the 0 equals 1. Anytime anything is to the 0, it equals 1. Whether it's my favorite number to the 0, that equals 1. My initials to the 0 equals 1. My favorite movie to the 0 would equal 1. Anything to the 0 at any time is always equal to 1. Rules 6 and 7 are pretty similar, and they work a lot like the distributive property. On the left side over here, we have a, b in parentheses to the x. That means that both of those need to be raised to the x. We can rewrite that. We're not technically distributing, but it's going to work the same. We need to apply the x to both the a and the b, and that's how we end up with a to the x times b to the x. So this first example, we can do the same thing. We can do x to the third and y to the third. We're applying the 3 to both of those. So you could rewrite that as x cubed, y cubed. We can do the same thing on this right side with the 5. The 5 is going to need to be applied to the x, the y, and the z. So we have x squared to the 5th times y cubed to the 5th times z to the negative 1 to the 5th. This is a great example. It's going to combine a lot of the rules we've already learned. If we just focus on the x, we have x squared to the 5th. That's power of a power, or rule number 3. So this is x to the 10th. Y cubed to the 5th is going to be y to the 15th. And then z to the negative 1st to the 5th. We're going to multiply those and get z to the negative 5th. Now the one other thing we need to do, a red flag for you, needs to be negative exponents. You can't leave any negative exponents in your answer. Since we have a z to the 5th, technically it's upstairs. It's on the top of a fraction. We can rewrite this as x to the 10th times y to the 15th, and that z to the negative 5th can become z to the 5th downstairs, and that would be your final answer. Same thing works for our last rule. A divided by b is raised to the x. The x needs to be applied to both the numerator and the denominator, so we end up with over here a to the x over b to the x. Now again, these examples are going to combine a lot of our rules, so they're a good place to wrap up. If we take this negative 2 and apply it to both places, we end up with x to the negative 2 over y to the negative 2. We know negative exponents we can't have in our answers. We can use our upstairs downstairs theory. X to the negative second upstairs can become x to the second downstairs. Same thing with the y. Y to the negative second downstairs can become y to the positive second upstairs. Your final answer is y squared over x squared. We take a look at this second example. We have x squared. That needs to be raised to the 4th. The bottom also needs to be raised to the 4th, so y to the negative 3rd to the 4th. That's going to give us x to the 8th over y to the negative 12th. We see again another negative exponent. Y to the negative 12th downstairs can be written as y to the 12th upstairs. So your final answer here is going to be x to the 8th times y to the positive 12th. So that's it for the rules. Couple general rules we talked about. When you want to know if you have your final answer, if your expression is fully simplified, you need to check that all like bases are combined. So you can't have any two terms with the same base, and you can't have any negative exponents in your answer.